Hello and welcome to this demonstration of world's first 60,000 megawatt solar panel power plant. How it works is, let's see the parts first. This is a dam, and this red area is supposed to be the spillway. The dam generates 2,500 megawatts normally, but its peak capacity is 5,000 megawatts, which it never does because there is not enough water in the dam. And this water area can be acquired, which is already paid for land. It has been paid for. It belongs to the government, and it is a very good source of fish farming, and that's what it is. Now, let's see how we will generate 60,000 or 12 times the electricity that this dam was supposed to generate, or it is generating with the maximum available capacity. In order to understand, you have to know the fact that this entire dam constitutes 150 miles of water. We will cover the entire dam with floating solar panels, as you can see here. In this demonstration, what we will show you is there is a meter that right now you may not be able to see, but it is reading around 56 or 56 presumably 1,000 megawatts. These are the 6 batteries, presumably each one capable of peak production of 10,000 megawatt each. Because if you spread it over on 150 miles, it can generate 200,000 megawatts or close to that. So we left so much of area uncovered because we only want to demonstrate with 60,000 megawatt output. One question that gets asked is, what if there are waves? Of course there will be waves, and let us generate them. And those solar panels will keep on shaking but keep on stabilizing as the waves stabilize. Or even if they don't, see, while it is shaking, okay, it is still generating more or less same energy. About 1% of energy was being lost because of the waves. That means we will probably, instead of 60,000 megawatts, we will generate 58,000 megawatts because of these waves. And now let us show you what will happen if there is rainfall on the solar panel. And let's create that. And while the rain is falling, as you can see, it is still 57,000 megawatts. Now, what if this was to be covered by shade? So let us cover that with a shade on the solar panels, and if we go look at the meter, it is generating 54,000 megawatts presumably. Now, this means that during a cloudy day it will generate somewhat less, let's say about 10 megawatt less. But that part of the world where it is being considered to be installed, 90%, 95% full sunlight is there. Days are longer than they are in New Jersey, USA. So we are 100% sure that this will generate far more energy than the same kind of farm would have generated in New Jersey. Snow almost never falls, and that means those panels will only be exposed to water, not to snow. Because snow-covered panels, of course, will need more cleaning, more snow removal and all that. We don't want that. Now, let us discuss the economic part of it. Zero acquisition cost, that's what we are talking about. $0 to acquire the land, because we are not using 1 square inch of land for that purpose. Then, if it was to generate about not 58,000 or 54,000, but even 50,000 megawatts at its peak or average of 50,000 megawatt, 11 hours a day, 11 months, 12 months a year, then we are looking at $20 billion revenue, billable revenue generations calculated at 8 cents a kilowatt hour. That's incredible price for consumer. Now, there is no more wiring needed, no new wiring needed, because the dam is already wired to carry close to 6 or 7,000 megawatts of electricity if generated, which it never does. So the infrastructure is there. It never has enough power to carry around, and that is a waste. Now, if it was to generate $20 billion a year in revenue, and solar panels were to last 20 years or 30 years, we are looking at 160 billion times 2, 32 billion US dollars every in 20 years. And assuming that this much of all these solar panels were to cost $16 billion, very first years of revenue will pay it. No more oil, furnace oil, no more gas, no more coal, and other. This is the cleanest it can be.